Good morning, students, and we're here starting today's lesson outside with a little fire. It's a nice Saturday morning and I'm making these videos weeks or days in advance for you guys. So today's lesson isn't about the start of fire, it's something more exciting. It's the centroids. Alright? And as we can see from that activity above, that centroids are the center of gravity. It's the balancing point of a triangle. Alright, so it's good to be able to find it and do it with a physical triangle, something that you can hold. But you got to remember that we also do a lot of coordinate geometry here in GAC 1. Okay, so we're going to throw a triangle on a coordinate plane, and you can find it by using math and stuff we know about coordinates. Alright, so first we're going to use coordinate geometry. We're going to what is the distance from C to the centroid? So first off, we just got to find the midpoints. We're going to do this quite quickly, like looking at line AC. This has a length of 1, 2, 3, 4, 5, 6. So the midpoint is going to be 1, 2, 3. Boom. And I connect B, and we'll call that lowercase b. And this green segment we just drew is a median. Now remember, when you drive down the street and those grass dividers in the middle of the road, that's a median. It's in the middle. All right, same stuff. We're gonna do this for let's do this for AB now. All right, now we can count, like, let's count this horizontal distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I really just want to go 6. So 1, 2, 3, 4, 5, 6. That's where the midpoint should be. Because I went from 6 up to here, and I just translated to where it was actually on the line, and boom. That's the centroid from there. So technically, I already found the balancing point. It's where these two segments intersect. The third one's guaranteed to be right through that as well. So technically, I can kind of cheat and just do. Hold on. Yeah. Time out. Minor brain part right there. I was thinking about something else. That's gonna go right there. Boom. We'll call that lowercase a. And then for some reason, I can't give you a good reason, they like to call the centroid the balancing point, point P. Alright? So we're just going to do some quick math, some quick calculations, and there's some relationship with centroids, their lengths, and the distance to the centroid, and from the angles and midpoints and all this fun stuff. So what's the distance from point C to the centroid? And it's asking us specifically about this length right here. It's 4. 1, 2, 3, 4. Alright, and what's the distance from the centroid to the midpoint on segment AB? So this was the midpoint on segment AB. What's that distance? 2. And what do we notice? It depends on how you think about it. Going this way, we can say, well, it's half. Or if we go this way, it's double. So depending on how you look at it, one length's half the other, or one length's double the other length. Alright, so that's kind of interesting. If you go from angle to the centroid, or from the centroid to the midpoint, one segment's going to be double the length. Alright? And remember, centroids are third center. We have the circumcenter, the end center, now we have the centroid. Alright? Let's see. Now it's going to ask us, what is the distance from point A to the centroid? So we need to use the Pythagorean theorem shortcut for this. So looking at this, I mean, we got a lot of colors going on right now. Make sure you guys are writing down everything in your notes. Alright? Mr. Vote and myself, we're the ones grading it. If you guys aren't writing something down, probably going to take off some points. Alright? These things aren't optional to write. We really want you to write it down. It's about the process. 1, 2, 3, 4, 6. Alright? So we can use Pythagorean theorem shortcut. C squared equals 4 squared plus 6 squared. Alright, c squared equals 16 plus 36 c squared equals 52. C equals the square root of 52. And let me get my calculator really fast. It's going to be bigger than 7.2. All right. And then it says do the same thing from the centroid to the midpoint on BC, which we called lowercase a. So now it's really just asking for this. So we're going to use Pythagorean theorem shortcut again. 2, 3. All right, in this case right here, we're going to get c squared equals 2 squared plus 3 squared. And remember, if these videos are going too fast, you guys can always pause them, rewind them. You guys might think that they're going perfect speed. Who really knows? So c equals the square root of 13, which is about 3.6. So again, we saw that half, double. Just depends on how you look at it. Nice. All right. We'll do the other ones in another video.